Last kind of polymer that we're going to look at is an addition polymer. And addition reactions, you'll remember, use a double bond. It breaks the double bond and adds something onto each of the carbons. So what's going to happen with addition polymers are we're going to have a double bond, and when it breaks, it's going to make it so that you get electrons that can form like kind of sticky ends where they're going to stick together. And so if a polyethylene or polyethylene is where they've just used an ethene and it just keeps adding an ethene onto each end. And so at this carbon and at this carbon, they can add another ethene. And it creates this extremely long alkane chain. And so, your polyethylene bags, like your store bags that are so bad for the baby turtles and stuff like that, those are made out of ethene and they repeat them. But this pattern works for the other addition polymers. So it gets more interesting when I've got something like propene. So propene has got CH2, double bond CH, CH3. Well, I'm going to still get these two carbons are where you add it. And so what they've drawn here is they draw the double bonds lining up. So if that's not obvious, you can see that the double bond, double bond, double bond, and then on every second carbon, you're going to get a methyl that looks like it's branching off. So when I look at the polymer, I get my chain, and on every second carbon, I get this repetition. And so it looks like this. So whenever I've got a monomer that's got a double bond, I like to kind of draw everything else coming off like it's branches. So here, vinyl chloride is going to be Cl bonded to CH double bond CH2. But we're going to draw the hydrogens and the chlorine off like they're branches. And what we're going to see is that every second carbon has a chlorine because you can see one of the two carbons has a chlorine. If you had polystyrene, styrene is going to have CH double bond CH2, and this is attached to a benzene ring. And so this benzene ring occurs on every second carbon, right? And so if I look at the polymer, I'll see, oh, I've got this on every second carbon, then I must have a CH2, and this is going to be bonded to a benzene, and there's going to be a hydrogen attached to it. And so if I look at the polymer, I can identify what the monomer would be. So here we've got polytetrafluorine or Teflon. Now Teflon has got two fluorines on every carbon. So this must have had a fluorine, a fluorine, a fluorine, and a fluorine, right? In order to be able to have fluorine saturate the entire polymer, it means that all of the carbons must have been filled up with that. And so that's how addition polymers work. I'm going to ask you to do all of the polymer questions, and hopefully it's easy enough to spot what the monomers would make for a polymer. If they showed you the polymer, what were the monomers that make it? Is it an addition polymer or an addition or polyester or an esterification reaction? Would it be a condensation polymer, which means it's giving off water? Is it a natural polymer or synthetic polymer? So identifying the kinds of polymers is quite useful.